Berlin. The autumn of 1859. A candle burns on a desk covered in papers. The man sitting there is 89 years old. He is, at this moment, one of the most celebrated scientists in Europe. Kings have sought his company. Darwin has been reading his books since he was a student. Napoleon, by several accounts, found him difficult to be in the same room with, not out of hostility, but because in any room they shared, the attention was never quite where Napoleon believed it ought to be. His name is Alexander von Humboldt. Within a generation of his death, almost no one will remember why. How does that happen? How does one of the most celebrated minds of the 19th century become a name that educated people can barely place? A bay on a coastline whose story almost no one can tell. The answer is the story we are going to tell tonight. It is the story of a man who looked at the natural world and understood, long before the modern age of ecology, that everything is connected, who helped give the modern world its idea of nature as an interconnected whole, who shaped the thinking of Darwin and Thoreau and John Muir, and then was quietly, almost completely, forgotten by the world his ideas helped create. Settle in. Tonight we travel back to the Prussia of the 1700s, to the jungles of Venezuela, to a mountain in Ecuador where one man stood at the edge of what was known and decided to go further. This is the complete life of Alexander von Humboldt. Chapter 1. The Wrong Son. The estate of Tegel sits about 8 miles northwest of the centre of Berlin, where the city eventually runs out of city and becomes lake and forest, and the particular quiet of the Prussian countryside. In the 1770s it was a modest property, not grand by the standards of the Prussian aristocracy, but solid and respectable, the kind of place that spoke of duty and order, and a family that understood its obligations to the world. The grounds were well kept. The household ran on schedule. Everything was as it was supposed to be. Everything, that is, except the younger boy. He was born on the 14th of September, 1769, less than 2 years after his brother Wilhelm, and, from the beginning, he seemed to be made of different material. Where Wilhelm was composed and focused, Alexander was restless. Where Wilhelm absorbed his lessons with quiet efficiency, Alexander struggled. He was a pale and frequently unwell child, slow to develop in the ways that counted in a household organized around achievement and propriety, and his mother found him difficult to read and harder to love with any visible warmth. Their mother, Marie Elisabeth von Humboldt, was not a cruel woman, but she was a woman of her class and her time, which meant she understood her sons primarily as investments in the family's position and reputation. Wilhelm was the obvious investment. He was thoughtful, disciplined, and exceptionally gifted with language and ideas. He would go on to become one of the great intellectuals of his age, a philosopher of language, a diplomate, the founder of the University of Berlin. History would remember him as Wilhelm von Humboldt, one of the finest minds of the Enlightenment. Alexander, in those early years, did not look like a comparable investment. Their father, Alexander Georg von Humboldt, was a Prussian military officer who had served in the court of Frederick the Great. He was gentler than his wife, reportedly fond of both boys in a more instinctive way, bringing into the house an occasional warmth that softened the edges of Marie Elizabeth's expectations. He died in 1779, when Alexander was only 9 years old. After that, the household belonged entirely to his mother. What remained for Alexander was a boy alone with his inner world. The tutors hired by Marie Elizabeth were excellent men. They worked through languages, mathematics, economics, and the political sciences appropriate for future Prussian officials. Alexander sat through these lessons with reasonable obedience. He was not stupid. His tutors noted his quickness, his memory, his ability to follow a complex argument once he chose to pay attention. The problem was that his attention was frequently elsewhere, because while the tutors taught, Alexander was conducting his own education in the forests and fields surrounding Tegel. He collected everything: insects, plants, rocks, shells, the small creatures that lived under stones and in the crevices of bark. He catalogued them with a seriousness that surprised the adults around him, labelling his specimens with careful handwritten notes, arranging them in systems of his own devising. The household servants called him the little apothecary. It was said with affection and mild bewilderment. The boy was gathering the world one small piece at a time, and no one quite knew what to make of it. His mother assumed it was a phase, a child's distraction from the serious work of becoming useful. She was more wrong about this than she ever knew. What no one around him understood was that he was not playing. He was working. The collection of beetles and mosses and mineral samples was not the hobby of an idle boy. It was the beginning of a method, a way of looking at the world that involved not just collecting the pieces, but wondering, always wondering, how they connected to each other. Why did this insect appear only on this plant? Why did this rock formation occur here and not 50 feet away? Why did the same moss grow on the north face of every tree in the forest, while the south face remained bare? These were not questions a child was supposed to ask. They were not questions that any tutor had been hired to answer. Alexander asked them anyway. He asked them in the forest, alone, with no one to hear. There is a particular kind of loneliness that comes with being the child who is not fully seen, whose interior life is rich beyond what anyone around them suspects, but whose richness remains invisible because no one has yet found the question that unlocks it. Alexander von Humboldt knew that loneliness from the inside. He carried it into the forests of Tegel. He carried it to his collection of specimens, arranged on shelves in his room. He carried it through the long Prussian winters, where the estate was cold and his mother was occupied with her own concerns, and the nearest thing to warmth was a lamp over a table covered in pinned insects and labelled stones. He was not happy in any simple way, but he was learning something that no tutor had taught him and no curriculum had planned for. He was learning to pay attention, to look at the physical world with the kind of sustained, patient, systematic attention that most people reserve for human affairs, to stay with a question past the point where staying with it was comfortable. He was learning to read the book of nature. He did not yet know what the book was about. That understanding would come from a teacher on the banks of a river, years later, who would show him that the separate pieces he had been collecting all his life were not separate at all, that the beetle and the moss and the stone and the river and the mountain were parts of a single story. But before that teacher, before the river and the revelation that came with it, there was still more waiting to be done, more lessons to endure, more forest walks that no one took seriously, more years of being the wrong son in a household that had already decided which son mattered. Alexander von Humboldt was 17 years old. The world had not yet introduced itself to him, but he was moving toward it, step by patient step, in a way that the world could not yet see and his mother could not yet imagine. Chapter 2. The Education of a Mind. In the autumn of 1787, Alexander von Humboldt arrived at the University of Frankfurt an der Oder as a young man of 18 who had spent most of his life being told, in one way or another, that he was not quite what was needed. Frankfurt an der Oder was not the destination his mother had envisioned. Göttingen was the finest university in the German-speaking world, the place where serious young men from serious families went to become serious people. But Alexander was not ready for Göttingen yet, not by his own assessment, and so he went first to Frankfurt, a smaller institution, to find his footing. He did not find it there. He found something more important. He found the first indication that the way he naturally thought about the world, moving between disciplines, connecting the behaviour of one thing to the behaviour of another, refusing to look at any phenomenon in isolation, was not a deficiency. It was a method. It was, in fact, a form of intelligence that the standard education of his time had no framework to recognize, let alone reward. After one semester, he moved to Berlin, where he studied finance and economics at his mother's urging. He sat through lectures on trade and taxation, with the patient endurance of a man waiting for the subject to become interesting. It did not become interesting, but Berlin gave him access to a wider world of ideas than Tegel had, and he read beyond his coursework with the voracious, undirected hunger of someone who has not yet found the question but knows the answer is somewhere in the library. Then came Göttingen. He arrived in the spring of 1789, and the difference was immediate. Göttingen, in the late 18th century, was one of the intellectual centres of Europe. Its faculty included some of the finest scientific minds of the age. Its library was extraordinary, and its culture, unlike most universities of the time, valued empirical observation alongside theoretical reasoning, the actual study of the physical world alongside the classical education that dominated everywhere else. Here, for the first time, Alexander von Humboldt found himself in a place that was built for someone like him. He studied geology and botany. He worked through the comparative anatomy of plants with a thoroughness that impressed his professors. He read everything he could find on the new science of electricity, on the movements of the atmosphere, on the structure of rock formations and what they revealed about the deep history of the earth. He moved sideways and diagonally across the boundaries, separating one subject from another, following connections that his professors sometimes struggled to see. But it was not a professor who changed everything. It was a man named Georg Forster. Forster was 35 years old when Humboldt met him at Göttingen in 1789, and he was already famous across Europe for one remarkable fact. As a young man, he had sailed around the world with Captain James Cook on Cook's second voyage. He had stood on islands in the Pacific that no European had visited before. He had seen the Southern Ocean and the extraordinary biological diversity of the tropics, and he had come back from all of it with a mind permanently altered by the experience of seeing how large and various and interconnected the natural world actually was. His book about the voyage, published in 1777, was remarkable not just as a record of exploration, but as a way of thinking about what exploration meant. Forster did not simply catalogue what he had seen. He thought about it. He compared the plants of one island to the plants of another. He noticed patterns. He asked why things were the way they were, not just what they were. This was exactly the kind of thinking that Humboldt had been doing alone in the forests of Tegel. Without a name for it, without a model, without anyone to tell him it was a legitimate way of engaging with the world. Meeting Forster was like being handed a mirror. They became close quickly. The experienced explorer and the restless young student. And in the spring of 1790, Forster took Humboldt on a journey along the Rhine River, south through Germany and into the Netherlands, and then across to England. It was not a dramatic journey by the standards of what Humboldt would later undertake. No jungles, no mountains, no genuine danger. But Humboldt later described the conversations of those weeks as among the most formative of his life. Forster talked about landscapes not as collections of separate features, but as systems of relationships. Each element connected to every other through flows of water and nutrients and climate and time. He talked about the natural world the way a musician talks about harmony, not as individual notes, but as the relationships between them. Humboldt had been collecting the notes his entire life. On the Rhine, he began to hear the music. He returned to Göttingen a different student. The separate disciplines he had been pursuing simultaneously, geology and botany and atmospheric science, and the emerging study of electricity in living organisms, were no longer separate pursuits competing for his attention. They were aspects of a single inquiry. Different instruments pointed at the same question. After Göttingen, he went to the mining academy at Freiburg in Saxony, where he spent the better part of a year studying geology and mineralogy with a practical intensity he had not brought to anything before. Freiburg was not a place of grand theory. It was a place of rock and measurement, and the hard technical knowledge of people who worked underground. Humboldt threw himself into it. He learned to read strata, to identify minerals by their physical properties, to understand how geological forces had shaped the landscapes he had spent his life walking through. He also began developing the habit that would define his scientific practice for the rest of his life. He measured everything: temperature, barometric pressure, the magnetic intensity of rock formations, the chemical composition of the air at different altitudes. He carried instruments the way other men carried letters of introduction. He believed that the natural world spoke a language of numbers as well as forms, and that true understanding required both the observing eye and the measuring hand working together. He was 21 years old. The architecture of the scientist he would become was in place. The foundations had been laid not by a curriculum or a plan, but by the accumulated pressure of 20 years of paying attention to the wrong things in exactly the right way. He was ready. He did not yet know for what. But somewhere beyond the forests of Tegel and the lecture halls of Göttingen, the world was waiting for him to arrive. Chapter 3. The Mines and the Body as Laboratory. In the spring of 1792, Alexander von Humboldt accepted a position as a mining inspector with the Prussian Department of Mines and took up his post in the Franconian mining districts of what is now northern Bavaria. He was 22 years old. It was, on the surface, exactly the kind of respectable government appointment his mother had always wanted for him. Practical, stable, connected to the real economic machinery of the Prussian state. His mother was pleased. She had no idea what he was about to do with it. The mines of Franconia in the 1790s were places of considerable hardship, dark, poorly ventilated, physically punishing environments where men worked in conditions that shortened their lives. Accidents were common. Lung disease was common. The particular misery of underground labour was simply part of the landscape, as unremarkable to those in authority as the cold and the dark. Humboldt arrived and found all of this immediately intolerable, not in a sentimental way. He understood the economic realities of the mining industry too well to imagine that sympathy alone could change anything. What he did, characteristically, was treat the problem as a scientific question. The miners were suffering from identifiable causes. Those causes could be studied, and if they could be studied, they could be addressed. Within months of his arrival, he had designed a new kind of safety lamp for underground work, a device that reduced the risk of gas explosions that were among the primary causes of mine disasters. He established a small school for miners, teaching basic principles of geology and mineralogy that would help them understand the environments they worked in. He studied the gas compositions of mine shafts, measuring the concentrations of carbon dioxide and other substances that accumulated underground and contributed to the respiratory illnesses slowly killing the men he worked alongside. This was not what mining inspectors did. Mining inspectors managed production quotas and filed administrative reports. They did not design safety equipment or run schools or conduct atmospheric experiments in the shafts on their days off. Humboldt did all of these things and filed the administrative reports as well. His superiors were simultaneously impressed and slightly baffled. The mines under his supervision became notably more productive, partly because workers who were less sick and less afraid worked better, and partly because Humboldt had a genuine gift for the practical geometry of underground work. He was promoted. His methods were recommended for wider adoption. But the most revealing work was happening in his private experiments. Humboldt had become intensely interested in the new science of galvanism, the study of electrical phenomena in living organisms. Luigi Galvani, in Italy, had famously shown that electrical current could cause muscle contractions in dead frogs, a discovery that sent a charge of excitement through the scientific world of the 1780s and 90s, and raised questions about the relationship between electricity and life that no one yet had satisfactory answers to. Humboldt wanted answers. He conducted hundreds of experiments, initially on animals, and eventually, with a thoroughness that alarmed the people who cared about him, on himself. He applied mild electrical currents to his own skin, to the muscles of his back and neck and arms, carefully documenting the responses with the clinical precision of someone who had decided that his own body was simply another instrument in the laboratory. He was not reckless. He understood the risks and managed them carefully, but he was absolutely clear, in a way that defined his scientific character throughout his life, that the boundary between the observer and the observed was thinner than most scientists of his time were comfortable acknowledging. He published the results in 1797, establishing himself as a serious scientific figure in Germany and beyond. He began corresponding with the leading naturalists of Europe. He exchanged letters with Johann Wolfgang von Goethe, the great poet and natural philosopher who became a friend and intellectual companion, letter by careful letter. He was building the network of scientific relationships that he understood to be as important as any single piece of research. And all the while, the restlessness grew. Because the mines were a laboratory, and he had used them as one, but they were a small laboratory. The questions forming in his mind were larger than any mine shaft could contain. He wanted to know how the whole natural world was organized, how the distribution of plants across altitude related to their distribution across latitude, how the temperature of ocean currents influenced the climate of coastal regions thousands of miles away, how the geological history of one continent connected to the geological history of another. These were questions that could only be answered by going out into the world. He began applying for permission to travel, to join scientific expeditions, to attach himself to diplomatic missions that would take him to the places he needed to go. The applications went out, and the rejections came back, and the applications went out again. And Humboldt waited with the coiled patience of a man who has learned that waiting is not the same as stopping. Then, in November of 1796, his mother fell ill. She had been declining for some months. Moving through it with the same composure she had brought to everything, as though even illness were a matter to be managed efficiently. Alexander came to be with her in the final weeks. He sat at her bedside in the house she had run with such precise authority for so many years, the house where he had grown up being the wrong son, the house where his specimens had been tolerated but never quite understood, the house where warmth had arrived mostly through the door his father had occupied and had not fully returned after his father died. He watched her go, whatever distance had existed between them, and it had been considerable. It was still a death, still a loss, still the disappearance of the first person in his life, the one whose regard he had spent his childhood trying to earn and never quite managed to secure. He wrote to a friend in the weeks afterward with a quietness that suggested a grief more complicated than simple sadness, the grief of someone mourning not just a person, but the relationship they had always wanted and never quite found. The night after the funeral, the house at Tegel was very still. Alexander sat alone in the room that had been hers, surrounded by the ordered quiet of a life that had been organized around expectations he had never quite met. Outside the windows, the Prussian winter pressed against the glass. He would have been aware, sitting there, of a silence he had been inside his entire life, finally taking a different shape. The weight of her hopes for him, the specific and practical hopes of a woman who had wanted a useful official and produced instead whatever he was. That weight was gone. What remained was everything else. The inheritance passed to both brothers. Wilhelm took his share and continued the intellectual and diplomatic career that had always been expected of him. Alexander took his share and understood, with a clarity that felt nothing like relief and everything like purpose, that the last external constraint on the direction of his life had been removed. He was 27 years old. He had an inheritance large enough to fund years of serious travel. He had a scientific education that was, by the standards of his time, genuinely exceptional. He had instruments and notebooks and methods and a set of questions that had been accumulating since childhood with the pressure of water behind a dam. The dam was gone. He was going to find out what everything was made of. He was going to find out how everything fit together. The forests of Tegel had given him the habit. The mines of Franconia had given him the method. The inheritance from a woman who had never quite seen him had given him the means. Now all he needed was a door. Chapter 4. The voyage begins Canary Islands, and the first vision. The years between 1797 and 1799 were among the most frustrating of Alexander von Humboldt's life. He had the money, he had the instruments, he had the scientific preparation and the restless, accumulated energy of a man who had spent his entire life getting ready for something he could not yet reach. What he did not have was permission. In the late 18th century, the parts of the world that interested Humboldt most were not open to anyone who simply wished to go there. The Spanish Empire controlled most of South America, Central America, and large portions of what is now the southern United States. And the Spanish crown was not in the habit of allowing foreign scientists to wander through its territories, asking questions and taking measurements. A man who mapped your coastlines and catalogued your mineral resources and observed the conditions of your colonial population was a man generating exactly the kind of information that empires preferred to keep to themselves. Humboldt tried everything. He approached the French government about joining a voyage of scientific exploration being organized under Captain Nicolas Baudin. The voyage was delayed, then reorganized, then delayed again. He waited in Paris for months, attending lectures at the Natural History Museum, meeting scientists, sharpening his instruments and his ideas, watching the departure date recede into an indefinite future. He travelled to Marseille, intending to sail to North Africa, and found the port closed by quarantine. He considered joining a Swedish expedition to Lapland. He explored the possibility of travelling to Egypt. None of it came together. Each door closed in its turn. But Humboldt was not a man who experienced rejection as a reason to stop. He experienced it as information. And the information he was gathering during these years of waiting was not nothing. He was meeting the finest scientific minds in Europe. He was deepening his knowledge across every field that interested him. He was becoming, in the waiting rooms and lecture halls and scientific salons of Paris and Madrid, a scientist of considerable reputation even before he had conducted the great work that reputation would eventually rest on. And then, through a connection that demonstrated how much of history turns on the chemistry between specific people at specific moments, a door finally opened. In Madrid, in the autumn of 1799, through a series of introductions that began with the Saxon ambassador and moved through the Spanish court with a speed that surprised everyone, including Humboldt himself, he obtained an audience with King Charles IV of Spain. He brought his instruments, his publications, his letters of recommendation from the finest scientific institutions in Europe, and the particular quality of personal presence that everyone who spent time with him described as genuinely difficult to account for. The king granted him permission to travel through the Spanish territories of the Americas. It was an extraordinary concession, almost without precedent for a foreign scientist. Humboldt was given documents allowing him free passage through the Spanish colonial territories, access to their archives, and the right to conduct scientific observations wherever he chose to go. He sat with the documents in his hands and felt the weight of what they represented. 3 years of closed doors, a lifetime of preparation, and now, finally, a way through. His travelling companion was Aimé Bonpland, a French botanist he had met in Paris, a quiet and exceptionally capable man whose skill at collecting and identifying plant specimens was as fine as anyone in Europe. They had become close during the months of waiting, and Bonpland had agreed, with an equanimity that Humboldt always admired, to abandon his life in France and sail into the unknown for as long as the journey required. They departed from the port of La Coruña on the 5th of June, 1799. Humboldt stood at the rail as the Spanish coast disappeared behind them and felt, by his own account, a happiness he struggled to describe. Not the happiness of relief. Though there was relief in it after years of waiting, dining larger, the happiness of a man who has finally arrived at the beginning of the thing he was always meant to do. He began measuring immediately the temperature of the water, the temperature of the air, the direction and force of the wind, the colour of the sea at different depths, the luminescence of marine organisms at night. He was barely a day out of port, and already the notebooks were filling. The instruments were being deployed. The method he had spent 20 years developing was being applied to a canvas larger than anything he had worked with before. The first major landfall was the Canary Islands, a Spanish archipelago off the northwest coast of Africa, where the ship stopped to take on provisions before the long Atlantic crossing. They had several days before departure, and Humboldt used every hour. The great object of interest was Tenerife, and more specifically the volcanic peak at its centre, the mountain known as El Teide, one of the highest points in the Spanish territories and one of the most accessible high-altitude environments in the Atlantic world. Humboldt and Bonpland climbed it, not a leisurely tourist ascent, a scientific one, with instruments, with measurement at every significant change of elevation, with careful observation of the plant communities growing at different heights and the way those communities transformed as the altitude increased. And somewhere on that climb, at an altitude already higher than anything Humboldt had previously experienced, something clicked into place. He had noticed in his reading that plants growing at high altitudes often resembled plants growing at high latitudes. The cold northern regions far from the equator, alpine plants looked like Arctic plants. The vegetation of a Swiss mountaintop had qualities in common with the vegetation of Scandinavia or Siberia, even though those places were separated by thousands of miles. On the slopes of El Teide, watching the plant communities shift as he climbed, feeling the temperature drop and the air thin, Humboldt saw this pattern with a new clarity. Altitude and latitude produced similar effects on living things. A mountain was, in a sense, a compressed version of the entire range of climate zones from the equator to the poles. Climbing a mountain was like travelling from the tropics to the Arctic in a single day, watching the same sequence of vegetation zones unfold that would unfold if you walked north from the equator across the face of the earth. This was not a random observation. It was the first major piece of a larger pattern, a glimpse of the underlying structure of the natural world, the way that climate and altitude and latitude and the distribution of living things were all part of a single coherent system governed by principles that could be understood. Humboldt wrote it down. He measured the temperature at each vegetation zone. He recorded the species. He noted the altitude at which each community appeared and disappeared. He was already on the slopes of a Canary Island volcano before he had even reached the Americas, building the data set that would eventually become one of the most influential scientific images of the 19th century. The ship departed Tenerife and crossed the Atlantic. On the 16th of July, 1799, they sighted the coast of Venezuela. Humboldt stood at the rail, as he had stood leaving Spain, watching a new world arrive. The coastline was dense with vegetation, a wall of green unlike anything he had seen in Europe, so thick and various and alive that it was almost impossible to take in. The air was different, the smell was different, the light was different, more intense, more saturated with colour, as though the sun here were a different sun from the one that shone over Germany. He wrote in his journal that the sight overwhelmed him, that he felt it was too much for any single mind to absorb at once, and that he had the immediate and powerful sense that he had arrived at exactly the right place to ask the questions he had been carrying his whole life. He was right. Everything that followed proved him right. Chapter 5. Into the Amazon Rivers, Jaguars, and the Web of Life. The coast of Venezuela in the summer of 1799 was not a gentle introduction to the tropics. Humboldt and Bonpland arrived in Cumaná, on the northeastern coast, and stepped into a world that assaulted every sense simultaneously. The heat was not the moderate warmth of a European summer, but a deep, saturating presence that pressed against you from every direction and made the air itself feel substantial. The vegetation was not the orderly greenery of the forests he had grown up with, but something wilder and more extravagant, an unruly abundance of forms and colours that seemed to mock the very idea of taxonomy, and the insects were unlike anything he had prepared himself for. Humboldt had expected mosquitoes. What he encountered in the lowland forests and river margins of Venezuela was something that travellers who had been there before described as one of the more formidable aspects of tropical fieldwork. And those travellers had not been exaggerating. The clouds of biting insects that rose from the vegetation at dusk were dense enough to affect breathing. He documented this with the same careful attention he brought to everything, noting the species, estimating the populations, observing the patterns of their activity at different times of day and in different microenvironments. He was 30 years old, newly arrived in the tropics, being eaten alive, and taking notes about it. This was characteristic. Cumaná and the surrounding region kept them busy for months. There were plants to collect, geological formations to examine, the magnetic intensity of the rock to measure, the temperature of springs and rivers to record. Bonpland worked with the quiet, systematic efficiency that made him an ideal companion, collecting and pressing plant specimens with a thoroughness that would eventually produce one of the most significant botanical collections of the early 19th century. Humboldt measured everything and talked to everyone. He had a gift for languages that served him well in Spanish America, and he had a quality of genuine curiosity about human beings, about their history and their knowledge and their relationship to the natural world they lived in, that made him sought out by people who had learned to be suspicious of European visitors. He talked to indigenous guides and local farmers and colonial administrators and priests. He asked about the behaviour of rivers in different seasons, about the distribution of animals in different habitats, about the traditional knowledge of people who had been living in these environments for generations, and who had accumulated understanding that no European scientist had yet thought to ask for. He was not extracting information. He was genuinely interested, and the people he talked to recognized the difference. But it was the river journey that changed everything. In the spring of 1800, Humboldt and Bonpland set out on what would become one of the most remarkable journeys in the history of scientific exploration. Their goal was to navigate the Orinoco river system and find what was said to be a natural canal connecting the Orinoco to the Rio Negro, which flowed into the Amazon. The Cassiquiare Canal, as it was known, was doubted by most European geographers. The idea that two major river systems could be connected by a natural waterway seemed unlikely enough that many scientists dismissed the reports of local people and missionaries who claimed to have travelled it. Humboldt intended to find out. They travelled by dugout canoe with a small crew of indigenous paddlers and a Franciscan monk who served as guide and interpreter. The journey would cover approximately 1,700 miles over roughly 4 months, through rainforest, through flooded grasslands, through environments that shifted and changed in ways that demanded constant observation and constant adaptation. The conditions were severe. The mosquitoes were, if anything, worse than on the coast. There were stretches along the upper Orinoco where the insects were so numerous that eating without consuming them was impossible, where fires kept burning specifically to drive them away, provided only partial relief. There were jaguars. One came into their camp on the lower Orinoco and spent several minutes inspecting their equipment before departing, apparently unimpressed. Humboldt recorded this with the dry, factual tone of a man who had decided that the jaguar was more interesting as a scientific subject than as a source of alarm, and described the animal's movements and behaviour with careful attention to detail. There were caimans in numbers that made river crossings a calculation of risk rather than a simple matter of getting from one bank to another. And then there were the electric eels. Humboldt had been fascinated by electrical phenomena in living organisms since his days in the mines of Franconia. The electric eel, known locally as the temblador, was one of the most powerful bioelectric organisms known to science, capable of producing shocks strong enough to stun a horse. Humboldt wanted to study them directly. The method the local people used to collect them was one he described with a mixture of scientific excitement and barely concealed amazement. They drove a herd of horses and mules into a shallow lagoon where the eels were concentrated. The disturbance provoked the eels to discharge their electrical organs repeatedly in defence, exhausting them. After some time, during which several horses were overwhelmed by the intensity of the shocks and had to be pulled from the water, the eels were too depleted to defend themselves effectively. Humboldt then held them. He measured the electrical output with the instruments he had brought for exactly this kind of work, receiving shocks in the process that he described as among the most violent physical sensations of his life. He took careful notes. He compared what he was measuring to the experiments he had conducted on himself in the mine shafts of Franconia years before. He was in the middle of the South American rainforest, standing in a lagoon full of exhausted electric eels, running a controlled experiment. This was Humboldt at his most completely himself. But it was not the jaguars, or the caimans, or the electric eels that represented the most important discovery of the river journey. It was something that no single dramatic incident could capture. It was a pattern. As they moved through the forest month after month, covering mile after mile of the most biologically rich environment on Earth, Humboldt began to see with increasing clarity what he had glimpsed on the slopes of El Teide. The living world was not distributed randomly. It was organized in communities, each community shaped by the specific combination of conditions in its particular location. The same species appeared in similar conditions hundreds of miles apart. Different species appeared in adjacent areas where the conditions changed. The forest was not a chaos of individual organisms. It was a system of systems, each nested within a larger system, all of them connected by flows of water and nutrients and energy that moved through the landscape in patterns that could be traced and understood. He noticed that the health of the river system depended on the health of the forests surrounding it. Where the forest had been cleared, the rivers ran differently. The soil eroded differently. The microclimate changed in ways that affected everything downstream. He had conversations with missionaries who had been in the region for decades and who confirmed what he was observing. describing changes in river behavior following deforestation that aligned precisely with what his measurements were showing. He noticed that the indigenous peoples who had been living in these environments for centuries had developed practices and knowledge that were in many cases more ecologically precise than anything European science had produced on the same subjects. He wrote this down. He said it directly. In an age when European scientific culture routinely dismissed the knowledge of indigenous peoples, Humboldt's insistence on taking that knowledge seriously was itself a significant act. And he found the Cassiquiare Canal. It was real. The waterway connecting the Orinoco and the Rio Negro existed exactly as the local people and the missionaries had said it did. He measured it, mapped it, confirmed its existence beyond any reasonable scientific doubt, and sent the information back to the European geographers who had been skeptical, with the patient satisfaction of a man who has gone to look at something and found it there. They completed the river journey and returned to Cumana in the late summer of 1800. Both of them were weakened by the months of difficult travel. Both of them carried in their notebooks and their collected specimens the raw material of years of future scientific work. Humboldt spent his weeks of recovery writing. He filled journals with observations and reflections, trying to organize what he had seen into the beginnings of a coherent account, and in those weeks of writing, the idea that had been forming since the slopes of El Teide began to take a shape he could describe. The natural world was not a collection of separate things. It was a web, a living, dynamic, interconnected web in which every element was in relationship with every other element, in which a change in one part of the system produced changes throughout the system, in which the health of the whole depended on the integrity of the connections between the parts. This was not a metaphor. It was a description of how the world actually worked. No one had said it quite this way before, not in the precise, empirically grounded, scientifically rigorous way that Humboldt was beginning to say it. There had been poets who felt it, and philosophers who intuited it, and indigenous peoples who had always lived by it, but in the language of European science, with the data and the measurements and the systematic observation behind it, this was new. The foundation was in place, laid down in a dugout canoe on the Orinoco, in the notebooks of a man covered in insect bites who was measuring electric eels and talking to indigenous guides and watching the forest and the river and the slowly assembling pattern of the most important idea of his life. The web of life. He had found it. Now he had to figure out how to show it to the world. Chapter 6. Chimborazo, the mountain that changed everything. In the early months of 1802, Alexander von Humboldt stood at the base of a mountain in what is now Ecuador and prepared for the most important climb of his life. The mountain was Chimborazo. It rose from the high plateau of the Andes to a summit that, by the best measurements and understanding available at the time, was believed to be the highest point on earth. It was a dormant volcano, broad and white, and so massive that it seemed less like a mountain than like a feature of the sky, something permanent and elemental that had always been there and always would be, indifferent to the small creatures moving at its base. No European was known to have reached its summit. Several had tried. The altitude, the cold, and the technical difficulty of the upper slopes had turned them back. Humboldt looked at it and saw a laboratory. He had arrived in South America with questions about how the natural world was organized. The Orinoco journey had given him part of the answer, but he had been carrying since the slopes of El Tide a specific question about altitude and vegetation, about the way plant communities changed as you climbed. And Chimborazo, rising from tropical lowlands through every climate zone on Earth, compressed into a single vertical ascent, was the most complete possible version of the experiment he had been designing in his mind for 3 years. He needed to climb it. He set out in June of 1802 with Bonpland and a small party that included a young Ecuadorian nobleman named Carlos Montúfar, who had attached himself to the expedition with an enthusiasm that Humboldt found both touching and practically useful. The lower slopes were manageable. The forests of the middle elevations were extraordinary, dense with species that Bonpland collected, while Humboldt measured and recorded and observed. The temperature dropped steadily as they climbed. The vegetation thinned. The air began to feel different, thinner and less forgiving, each breath delivering slightly less than the last. Above the snowline, the mountain changed character entirely. The rock was covered in ice and loose scree, unstable surfaces that required careful movement and constant attention. There was no path. There was no guide who had been this high before. There was only the mountain going up and Humboldt going with it, step by careful step, instruments in hand, notebooks ready. His feet began to bleed. The thin leather shoes he was wearing, unsuited to this kind of ascent, had torn on the volcanic rock, and the sharp edges cut through to skin. His hands were numb. The altitude was producing the symptoms that high altitude produces in unprepared bodies: headache, nausea, a heaviness in the limbs that made each step require a separate, conscious decision. Bonpland was suffering similarly. Montúfar pushed on beside them with a quiet endurance that impressed even Humboldt. The other members of the party had turned back lower on the mountain, unwilling or unable to continue. At approximately 19,000 feet, a crevasse cut across the face of the mountain and stopped them. It was not crossable. The gap was too wide, and the ice on either side too unstable to attempt without equipment they did not have. The summit was still above them, perhaps 1,000 feet higher, visible in the clear cold air, but unreachable on this day. Humboldt stopped at the edge of the crevasse. He looked up at what he could not reach, and then he looked out at what surrounded him. He could see the curvature of the earth at the horizon. He could see the peaks of other Andean volcanoes rising from the plateau far below, Cotopaxi and Antisana and the others, like islands in a sea of cloud. He could see the gradient of the atmosphere above him, the sky deepening from blue to something closer to violet at the edge of the breathable air, and he could see, in his mind, connected to everything his eyes were showing him, the complete picture. He sat down on the ice at the edge of the crevasse, at nearly 19,000 feet, with bleeding feet and numb hands, and the symptoms of altitude sickness pressing against his concentration. And he drew. The drawing was a cross-section of Chimborazo, but it was much more than a cross-section. It was a map of the entire living world organized by altitude. At each elevation he marked the plant communities he had observed on the way up, the specific species that grew there, and the conditions that allowed them to grow. He marked the temperature at each level, the barometric pressure, the humidity. He noted where the permanent snowline began, where vegetation gave way to bare rock, where the last lichens clung to stone at the upper limit of life. and as he drew, he added comparative data from his memory and his notebooks. The plants at this altitude on Chimborazo resembled the plants at this latitude in the Alps. The vegetation zone at 10,000 feet here corresponded to the vegetation zone at this distance from the equator in Europe. The entire globe was present in the drawing. Each zone of Chimborazo, connected by invisible threads to corresponding zones on mountains and plains and Arctic regions thousands of miles away. He was drawing one of the earliest and most influential scientific images of the Earth as a connected living system. The image became known as the Naturgemälde, a German word meaning something close to nature portrait, and when it was published in the years that followed, it moved through the scientific world of Europe with the force of a genuinely new idea. It was not just beautiful. Though it was beautiful, it was conceptually revolutionary. It showed, in a single visual argument, that the distribution of life on Earth was not random, but followed principles that could be understood and mapped and used to ask deeper questions about why the world was the way it was. Darwin would later write that the quality of thinking he encountered in Humboldt's work had helped shape the framework through which he learned to see nature as patterned and connected. The Naturgemälde did not contain the theory of evolution, but it demonstrated that the living world had a structure and a logic that connected every living thing to every other living thing through the medium of the environment they shared. You could not look at it and continue to think of nature as a collection of separate things. They descended carefully, moving down through the vegetation zones that Humboldt had mapped on the way up, watching the temperature rise and the air thicken and the plants reappear in the sequence he had recorded. That evening, in their camp below the snow line, Humboldt wrote for hours by the light of a fire. He was trying to capture, while the experience was fresh, not just the data, but the sense of what he had seen, the feeling, powerful and persistent, that the natural world viewed from that altitude was not the world of separate things that conventional natural history described, but something unified and dynamic and alive in a way that the word alive barely captured. He would spend the next 3 years of travel and the following decades of writing trying to find language adequate to that feeling. Chimborazo stayed with him for the rest of his life. He referred to it in letters and lectures and published works across the following decades. When he was an old man in Berlin, still working, still writing, the mountain in Ecuador was still present in his thinking, a fixed point around which his understanding of the natural world continued to orbit. He never went back. He did not need to. Everything he had needed from the mountain he had taken with him when he walked down through the snow and the vegetation zones and the warm Andean air to the camp below, carrying in his notebooks and his memory the drawing he had made at the edge of a crevasse, the most important day of his scientific life. Chapter 7. The Return Fame, Paris, and A World Listening. Alexander von Humboldt sailed back to Europe in the summer of 1804, 5 years after he had left the port of La Coruña with Bonpland and a ship full of instruments and a set of questions that no one else had thought to ask in quite that way. He arrived with 42 cases of specimens and data, more than 6,000 plant species, of which approximately 2,000 were new to European science, thousands of measurements of temperature, barometric pressure, magnetic intensity, river currents, and ocean temperatures collected at locations across Venezuela, Colombia, Ecuador, Peru, Mexico, and the United States. Notebooks filled with observations, sketches and the beginning of a theory about the natural world that would take decades to fully articulate. He also arrived as a famous man. The letters he had been sending back to Europe throughout the journey, addressed to scientists in Paris and Berlin and London, and published in the scientific journals of the day, had been read with a mounting excitement he had not entirely anticipated. His account of the Orinoco journey, his work on the altitude distribution of plants, his measurements of the cold ocean current running north along the western coast of South America, his detailed reports on the geography and natural history of regions that European science had known only vaguely. All of it had arrived in fragments over 5 years and created, by the time of his return, an appetite for the full account that was larger than he had expected. Paris was where he landed, and Paris in 1804 was the intellectual capital of the world. Napoleon Bonaparte was first consul and would become emperor before the year was out. The city was in one of those periods of extraordinary cultural energy that sometimes follow political upheaval, when the destruction of old certainties creates space for new ideas. The scientific establishment of Paris was the finest in Europe, and its leading members received Humboldt with a warmth that reflected both genuine scientific admiration and the pleasure that serious people take when someone arrives from far away with exactly the information they have been wanting. He was welcomed everywhere. He gave lectures that drew audiences far larger than the scientific establishment alone, attended by educated Parisians who had been following his journey in fragments and now wanted to hear the full account from the man himself. He was elected to scientific academies. He was sought out for conversation by everyone who considered themselves part of the intellectual life of the city. Several accounts from the period describe Napoleon as visibly uncomfortable with the attention Humboldt was receiving at court, making pointed remarks about Humboldt's scientific interests in the way of a man who has decided that another person's fame is a mild, personal inconvenience. Humboldt navigated these encounters with the careful diplomacy of a man who needed the goodwill of the French government to continue his work, while maintaining the independence of mind that made him worth talking to in the first place. It was not a warm relationship, but the most important encounters of those first months in Paris were not with Napoleon. They were with the scientists who would become, over the following decades, the audience for the great work he was only beginning. Georges Cuvier, the great anatomist, Pierre-Simon Laplace, whose work on celestial mechanics Humboldt had been reading since university, and Joseph Louis Gay-Lussac, the chemist, with whom Humboldt ascended in a hot air balloon to a significant altitude above Paris, taking atmospheric measurements on the way up and the way down, with the cheerful disregard for personal comfort that characterized both men's approach to scientific inquiry. He was back in Europe, in one of the great cities of the civilized world, surrounded by comfort and admiration and every convenience, and his instinct was to get as high as possible and take measurements. Some things do not change. Then came Washington, in the spring of 1804, before returning to Paris to begin the long work of writing up his findings. Humboldt travelled to the United States and spent several weeks in the young republic. He met President Thomas Jefferson, and the meeting between these two men was one of those encounters that seems, in retrospect, almost arranged by history. Jefferson was 61 years old, in the second year of his second term, a man of extraordinary intellectual range who had spent his life thinking about natural history, geography, agriculture, and the future of a country still defining itself. He had read what he could find of Humboldt's reports from South America and had been eager to meet the man behind them. In the days and conversations that followed, Jefferson's letters describe a genuine intellectual pleasure, the warmth of a mind meeting another mind, operating at a comparable level of curiosity and ambition. They discussed the geography of the continent, the river systems of North America, the natural history of the West that the Lewis and Clark expedition was, at that moment, exploring. They talked about the political future of the Americas, about the relationship between the Spanish colonial territories and the independence movements beginning to stir in them, and they talked about slavery. Humboldt had travelled through territories where slavery was the foundation of the colonial economy. He had seen it in Venezuela, in Cuba, and now in the southern United States. He had observed its workings and reached a conclusion that he stated directly, in conversation and in his published work. The data did not support the arguments made in its defense. The social and moral costs of the institution were, in his assessment, incalculable. A society built on slavery was building on a foundation that would, over time, undermine everything constructed above it. This was not a common position in the scientific world of 1804. Most European scientists who engaged with the question treated it as a social and political matter beyond the scope of natural history. Humboldt disagreed. He thought the evidence was clear, and he said so. Jefferson listened. He was himself a slaveholder, a fact that sat in permanent and painful contradiction with the principles he had written into the founding documents of his nation. The conversation between them on this subject, which Jefferson's letters reference without fully recording, must have been one of the more uncomfortable exchanges of Humboldt's visit. A German scientist, not yet 40, presenting to the author of the Declaration of Independence the case against the institution on which the economy of his state depended. Humboldt was not naive about the limits of what one conversation could accomplish. He knew that the gap between understanding something and acting on it was often very large, and that the larger the interests arrayed against action, the larger the gap tended to be. But he believed that saying true things clearly was itself a form of work, that the accumulation of clear statements of uncomfortable truths eventually shifted the ground on which decisions were made. He said true things clearly. He returned to Paris in the summer of 1804 and began to write. The scope of what he had to write was staggering. 42 cases of specimens, thousands of pages of notes, a set of ideas about the natural world that required not one book but many, not a single argument but an architecture of arguments that would take decades to build. He started with the narrative of the journey itself, the account of what he had seen and done and thought during 5 years in the Americas. He wanted to write something that was not simply a scientific report, but a work that could be read by anyone with sufficient education and curiosity, that would convey not just the data, but the experience of being in those places and thinking those thoughts. He wanted to change not just what people knew, but how they felt about the natural world. The first volumes appeared in the years following his return, and were received with the kind of attention that confirmed his sense that the audience for this work was larger than the scientific establishment alone. Educated readers across Europe read his accounts of the Orinoco journey, of Chimborazo, of the political and social conditions of the Spanish colonies, with an appetite that reflected both the quality of the writing and the hunger of a readership that had been following fragments of his story for years. He was not yet 40 years old. He had barely begun the writing that would occupy the next 5 decades. The great ideas were in the notebooks and the memory and the still-forming vision of the natural world that he had been building since childhood and was only now beginning to have the material to express fully. But the world was listening. That was new. He had spent his childhood being the wrong son. He had spent his 20s waiting for permission to go somewhere. He had spent 5 years in the field, taking measurements that no one had requested because he was certain they mattered. Now the world was listening. He sat down at his desk in Paris, surrounded by the 42 cases of the most significant collection of natural history data assembled in a generation. And he picked up his pen. There was a very great deal to say, and for the first time in his life he had an audience large enough to hear all of it. Chapter 8. The Invention of Nature, Humboldt's Radical Idea. There is a question worth pausing on before we follow Humboldt further into the decades of writing and influence that lay ahead of him. The question is this: what exactly did he change? Not in the sense of which books he wrote, or which mountains he climbed, or which famous people he corresponded with. Those are facts about a biography. The deeper question is about ideas, about the specific shift in human understanding that Humboldt produced, the thing that was true after him that had not been true before him, the way of seeing the natural world that we have inherited from him so completely that we no longer notice we are using it. To understand what he changed, you have to understand what was there before him. Picture a naturalist in the European tradition of the 17th or 18th century. He is standing in a forest. In his hand is a notebook. He is describing what he sees with careful precision: the height of the trees, the structure of the leaves, the colour of the flowers, the behaviour of the insects visiting them. He is doing excellent work. He is adding to the sum of human knowledge about the natural world in a way that is rigorous and valuable and genuinely scientific by the standards of his time. But there is a question he is not asking. He is not asking why the forest is the way it is. He is not asking what produced the specific combination of conditions that allows this particular community of plants and animals to exist in this particular place and not somewhere else. He is not asking what would happen to everything else in the forest if the river upstream were diverted, or the canopy above were cleared, or the soil beneath were stripped of the organisms that kept it productive. He is not asking how this forest connects to the forest 200 miles away, or to the ocean current off the coast, or to the rainfall patterns of the continent, or to the lives of the people who depend on the watershed it feeds. He is describing the collection. He is not yet seeing the system. Carl Linnaeus, the great Swedish naturalist, whose system of biological classification remains the foundation of how we name living organisms today, exemplified this approach at its finest. Linnaeus looked at the living world and saw species, thousands of species, each with its own characteristics, each fitting into a hierarchical system of genus and family and order and class that organized the collection into something manageable and navigable. This was a genuine achievement. The Linnaean system was and remains one of the great intellectual tools of biology, a way of organizing information about living things that has proved durable enough to survive 2.5 centuries of scientific revolution. But it was a system for organizing a collection, and a collection is not the same thing as a system. Humboldt understood this distinction not as a theoretical proposition, but as something he had seen with his own eyes. felt with his own body, measured with his own instruments in the forests of Venezuela and on the slopes of Chimborazo and in the mine shafts of Franconia. He had watched the river change when the forest upstream was cleared. He had watched the plant community change when the altitude changed. He had watched the behavior of one species shift when the conditions that supported another species shifted. He had accumulated, over decades of fieldwork on 3 continents, a body of direct experience that made the connected nature of the natural world not a philosophical position but an observable fact. The German word he used for what he was describing was Naturganze. It translates roughly as the whole of nature, and it captured something that single English or French words did not quite manage. The idea that nature was not a collection of separate things, but a single interconnected whole. A system in which every part was in relationship with every other part, in which change in one place produced change everywhere else, in which the health of the whole depended on the integrity of the connections between the parts. This sounds familiar to us now. It sounds like the basic vocabulary of environmentalism, of ecology, of the way educated people in the 21st century routinely think about the natural world. When we talk about ecosystems, about biodiversity, about the way deforestation affects rainfall patterns, or the way ocean temperatures affect weather systems, we are speaking a language that Humboldt did not invent alone, but that he, more than any other single figure, helped bring into the mainstream of scientific thought. But in 1800, this was not obvious. It was not the dominant framework. It was a radical proposition. Consider what it implied about the relationship between human beings and the natural world. If nature is a collection, then human beings stand outside it. We study it, use it, extract value from it, rearrange it to suit our purposes. The collection exists for us. We are its audience and its beneficiaries and its managers, but we are not part of it in any fundamental sense. If nature is a system, everything changes. If nature is a system, then human beings are not outside it. We are part of it. We are one element among millions in a web of connections that does not recognize the boundary between human affairs and natural affairs. Because there is no such boundary, what we do to the web, we do to ourselves. The deforestation that changes the river behavior, that changes the microclimate, that changes the agriculture, that changes the lives of the people who depend on that land, is not a story about nature and a separate story about human beings. It is one story, a story about a system in which every part is connected to every other part. Humboldt did not simply assert this, he showed it. He showed it in the data he collected on the Orinoco, where he observed directly the relationship between deforestation and river behavior and microclimate change. He showed it in the Naturgemälde, where the distribution of plant communities across altitude was visibly connected to their distribution across latitude, demonstrating that climate and life were organized by principles that operated at a global scale. He showed it in his analysis of the cold ocean current running north along the western coast of South America, tracing its influence on the climate and agriculture of the Pacific coast with the careful attention of someone who understood that an ocean current was a thread in a web connecting the sea to the land, to the air, to the lives of every human being in the region. And he showed it in what he was beginning to observe about what human activity was doing to that web. This is the aspect of his thinking that makes him feel most urgently contemporary. Humboldt had been watching, in the Spanish colonial territories he travelled through, the effects of large-scale land use change on the natural systems of those regions. He had seen that clearing forests for agriculture changed the water cycle in ways that eventually reduced the productivity of the land that had been cleared. He had seen that the draining of lakes and the diversion of rivers altered the microclimates of surrounding areas in ways that no one had planned for, and that the people responsible for those decisions did not fully understand. He had seen the long-term consequences of treating the natural world as a collection of resources rather than a web of relationships. He wrote about all of this, not as an activist making a political argument, but as a scientist describing what the data showed. He also understood something that made his observations particularly difficult to dismiss. The degradation he was describing was not an accidental byproduct of progress. It was the result of a way of seeing. The people clearing the forests and draining the lakes and exhausting the soil were not doing these things carelessly. They were doing them rationally, according to the logic of a system that treated the natural world as a collection of resources. The problem was not their behaviour in isolation. The problem was the framework that made that behaviour seem reasonable. Change the framework and you change the behaviour. This was why Humboldt invested so much of his energy, not just in scientific papers addressed to specialists, but in books and lectures and letters addressed to everyone. He was not trying to inform the scientific community about data it could find elsewhere. He was trying to change the way human beings understood their place in the natural world. To replace the framework of the collection with the framework of the system, to make the connections visible to people who had never been shown them, and who, once shown them, might choose to act differently. He was not naive about how long this would take. He had watched the gap between what the evidence showed and what the people in a position to act on it chose to do throughout his entire adult life. He watched it with the deforestation in South America. He watched it with slavery. He knew that clear evidence and clear argument were necessary, but not sufficient. That the interests arrayed against change were often large and well organized, and entirely capable of acknowledging a problem in principle while declining to address it in practice. But he believed that the work was worth doing anyway. That every person who came to understand the natural world as a connected system rather than a collection of resources was a person whose decisions over the course of a life would be different from the decisions they would otherwise have made. That the accumulation of those different decisions across generations of people who had been helped to see clearly was the only mechanism by which the relationship between human civilization and the natural world could be changed in any durable way. Education as the long game, understanding as the foundation of everything else. This belief ran through every book he wrote, and every lecture he gave, and every letter he sent across 5 decades of public life. It was what made his writing so different from the scientific writing of his contemporaries. He did not write for specialists. He wrote for everyone. He used language that was precise enough to satisfy scientists and vivid enough to move people who had no scientific training. He described landscapes with the attention of a painter and analyzed them with the precision of a physicist. And he did both at the same time, in the same sentences. He wanted people to feel what he felt on the slopes of Chimborazo, the feeling that the world was larger and more connected and more magnificent than any conventional description of it could capture. The feeling that being alive in this world was not a fact to be managed, but a gift to be understood. The feeling that the connections were real, and that they mattered, and that seeing them clearly was the beginning of everything. That feeling, he believed, was where science and art and the protection of the natural world all began. In the same place, at the edge of a crevasse on a mountain in Ecuador, with the whole connected world spread out below. Chapter 9. The Russian Expedition's Step, Siberia, and a Warning. In the spring of 1829, a letter arrived at Humboldt's apartment in Paris from the court of Tsar Nicholas I of Russia. Humboldt was 59 years old. He had been living primarily in Paris for most of the previous 2 decades, writing and corresponding and attending scientific meetings, moving through the intellectual life of the city with the ease of a man who had become, over 30 years of published work and public reputation, one of the most recognized scientific figures in the world. He had not done significant field work since the American journey. He missed it with a persistence that his letters from this period make clear. There was a restlessness beneath the Parisian life of manuscripts and salons that was the same restlessness that had driven him into the forests of Tegel as a boy. The same need to be in direct contact with the physical world rather than describing it from a desk. He was a scientist who believed that understanding came from contact, from the measuring hand and the observing eye pressed against the actual surface of the world. And the surface of the world had been too far from his desk for too long. The letter from the Russian court offered him exactly that. The Russian government wanted Humboldt to travel through the empire, visiting the mining districts of the Ural Mountains, the steppe of Central Asia, and the borderlands near China, to provide a scientific account of the natural history and mineral resources of these regions. The invitation came with the full support of the imperial government, which meant access to resources and transportation and official assistance of a kind that made large-scale scientific travel possible in ways that private funding alone could not achieve. It also came with unspoken expectations. Russia, in 1829, was an autocratic state with a large serf population and a government that did not welcome frank assessments of its social conditions from foreign visitors. Humboldt understood this. He accepted the invitation and managed the expectations with the diplomatic skill he had been developing since his first audiences with Spanish colonial officials 30 years before. He would observe what he came to observe. He would say what the evidence warranted saying. He departed in April of 1829 with 2 companions, the mineralogist Gustav Rose and the naturalist Christian Gottfried Ehrenberg, and a larger support party arranged by the Russian government. The journey covered more than 20,000 kilometers over 9 months. To place that in perspective, it was roughly equivalent to traveling from New York to Los Angeles and back 4 times. Across terrain that ranged from the agricultural plains of western Russia to the granite peaks of the Ural Mountains, to the vast open steppe of Kazakhstan, to the semi-arid borderlands where the Russian Empire approached the edges of China, Humboldt measured everything, as he always had. He measured the magnetic intensity of rocks across the entire span of the journey, building a data set that contributed to the understanding of the Earth's magnetic field and its variation across longitude. He measured temperatures at depth in the Earth, in mines and natural shafts across the Urals. He observed the geology of the Ural Mountains with particular attention, noting the similarities between their rock formations and those of corresponding ranges in other parts of the world, strengthening the argument he had been making for decades that the geological history of the Earth was a single, connected story. But it was during a particular evening on the open steppe, somewhere east of the Ural Mountains, that the journey produced its most quietly significant moment. The party had made camp as the sun went down over a landscape that extended in every direction without interruption. Flat and vast, and so empty of human presence that the sky above seemed larger than any sky Humboldt had seen since the open Atlantic. The air was dry. The grass of the steppe moved in a wind that had been blowing. It seemed, since before any of them were born. Humboldt sat outside the tent with his notebooks and his instruments, taking the evening measurements he took every day, regardless of where he was. Temperature, barometric pressure, the magnetic readings that had become a kind of daily conversation with the earth itself. And as he worked, he was also looking at the landscape around him with the accumulated attention of a man who had been watching landscapes for 40 years. The steppe was changing. He had been talking to people across the journey, in the settlements and trading posts that dotted the route, people who had lived in these regions across generations and who spoke about the land, the way people speak about something they have watched for a very long time. The old ones described a steppe that had been different, veta, more varied, with stretches of forest on the margins that no longer existed, with water sources that had diminished or disappeared entirely. The causes were the ones Humboldt had been observing since the Spanish colonial territories of South America 30 years before. The removal of vegetation, the intensive grazing that stripped the soil of its protective cover, the burning of forests on the margins to create more grazing land, the diversion of water for agriculture in ways that altered the behaviour of rivers and reduced the rainfall that depended on the moisture those rivers and their surrounding vegetation put back into the air. He wrote about this in his notebooks that evening on the steppe, connecting what he was seeing in Russia to what he had observed in Venezuela and to the larger pattern he had been assembling for 3 decades. The relationship between human activity and the climate and landscape of a region was not a local phenomenon. It was a principle that operated wherever human beings had been modifying the natural systems of the land at sufficient scale and for sufficient duration. He was among the earliest scientists to describe this principle in empirically grounded terms, drawing on direct observation across multiple continents. His strongest and most detailed documentation concerned deforestation, the modification of water systems, and the alteration of land cover, the areas where his fieldwork over 4 decades gave him the most direct evidence. He wrote about these observations and their implications in the published work that followed the Russian journey, and he said clearly, in language that did not hedge toward comfort, that the changes he was describing were not self-correcting, that a natural system altered at this scale and this pace did not simply return to its previous state when the pressure was removed. The changes were accumulating. Few in power chose to act on what he was describing. This was not surprising. The forces driving the land use changes he was observing were the forces of economic expansion, of the extraction of value from natural systems to support growing populations and growing states. And those forces had a momentum and a logic that individual scientific warnings, however well documented, were not going to interrupt by themselves. Humboldt knew this. He continued writing and speaking about what the evidence showed anyway, because he believed that the alternative, which was to observe the consequences of a way of treating the natural world and say nothing, was simply not available to a person who understood what he understood. He returned to Europe in the late autumn of 1829, crossing back through the Russian plains and the Prussian border into Berlin, carrying the data from more than 20,000 kilometers of a journey that had confirmed and extended the ideas he had been developing for 4 decades. The great fieldwork of his life was over. But the writing was not over. Not even close. Because now, at 59, with the data of a lifetime of observation in his notebooks, and the ideas that the data had produced fully formed in his mind, he was ready to begin the project that he had been moving toward since the forests of Teagle and the slopes of Chimborazo and the rivers of the Orinoco. He was going to write the whole story. Chapter 10. Cosmos, Writing the Universe. In the winter of 1834, Alexander von Humboldt sat down in his apartment in Berlin and began to write the most ambitious book of his life. He was 65 years old. The apartment was full of papers, stacked on the desk, arranged on the shelves, piled in the corners with the organized chaos of a mind that had been accumulating material for 60 years and had never quite found a filing system adequate to the task. The books were everywhere. The instruments from the Russian journey were arranged on a side table, still precise, still capable of measurement. The morning fire was lit. The coffee was made. He picked up his pen. The project had a name, Cosmos, from the ancient Greek word for order, for the universe understood as a harmonious and intelligible whole, as something that had a structure that could be described and understood, rather than a chaos that could only be endured. He was going to describe everything, not in the sense that every fact about the universe would appear in his pages. He was a scientist, not a deity, and he knew the difference. But in the sense that the book would attempt to show the universe as a whole, from the largest scale, the movements of galaxies and the structure of the cosmos visible through telescopes, down to the smallest, the chemistry of the soil and the behavior of the organisms that lived in it, all of it as a single connected system governed by principles that the human mind could grasp. He wrote every morning, rising before the sun, lighting the fire himself as he had always done, sitting at the desk while the Berlin winter pressed against the windows and the city slowly came to life around him. He wrote for hours before the first visitors arrived, before the correspondence that required answers, before the obligations of a man who had become, whether he sought it or not, the most recognized scientist in Europe. The correspondence was its own kind of work. A young scientist in Edinburgh had been reading his work on plant geography and wanted to know whether the patterns he had observed in the Andes corresponded to patterns anyone had documented in the mountain ranges of Africa. Humboldt wrote back with the specificity of someone who had been thinking about exactly this question and had opinions about it. A painter in Dresden was working on a series of landscapes depicting the volcanoes of South America and wanted to understand the geological relationship between them. Humboldt wrote back with sketches and explanations and references to the relevant sections of his published work. A student in Moscow had read his account of the Orinoco journey and was inspired to pursue a career in natural history and wanted to know what he recommended by way of preparation. Humboldt wrote back to the student with a list of books and a piece of advice that he had been giving young scientists for decades. Go out into the world, take instruments, measure everything, talk to the people who live in the places you visit, and never stop asking why things are the way they are. He did this while writing Cosmos. He slept very little. The first volume of Cosmos was published in 1845. It sold through its first printing within months, not just in Berlin, in Leipzig and Vienna and Paris and London. Translations were underway into French, English, Italian, Dutch, and Swedish within a year. Within 2 years, Cosmos was being read across Europe and in the Americas by scientists and educated general readers, and by people who had never read a scientific book before, but found in this one something that spoke to them in a language they had not known they were waiting for. What was it about the book that produced this response? The science was serious. The first volume covered the structure of the universe as understood by the astronomy of the mid-19th century, the formation of stars and galaxies, the structure of the solar system, the geology of the Earth, and its position in the cosmos. This was not science simplified for a general audience. It was a rigorous engagement with the best scientific understanding of the age, written by a man who had spent 60 years in direct scientific work and knew the material from the inside. But it was the way it was written that was unprecedented. Humboldt wrote about the universe the way a person writes about something they love, not sentimentally, not with the softening of difficult facts or the inflation of false certainties, but with the quality of attention and genuine wonder that comes from a lifetime of looking at the world closely and finding it, on every occasion, more extraordinary than the looking had previously suggested. He described a volcanic eruption with the precision of a geologist and the language of a writer who wanted the reader to feel the heat. He discussed the behavior of light in the atmosphere in terms that explained the physics and simultaneously conveyed the experience of standing on a tropical mountain at dawn, watching the colors change. He wrote about the history of human attempts to understand the cosmos with a generosity toward every tradition, European and non-European, ancient and modern, that reflected his genuine belief that the impulse to understand the natural world was one of the most admirable things human beings had ever done. He made the reader feel that being alive in this universe was not an ordinary thing. Scientific writing of the early 19th century did not typically do this. It was addressed to other scientists, written in the language of professional discourse, organized around the communication of specific findings. It assumed a reader who was already inside the discipline. Humboldt addressed a different reader, a reader who was educated and curious and capable of following a serious argument, but who needed, before they could engage with the science, to feel that the science mattered, that the questions it was asking were the questions worth asking. He gave them that first, and then he gave them the science. The response told him something he had believed for decades, but had not yet seen confirmed at this scale, that the audience for serious engagement with the natural world, for writing that treated the reader as an intelligent adult, capable of understanding difficult ideas, if those ideas were presented with sufficient clarity and care, was vastly larger than the scientific establishment had assumed. The second volume appeared in 1847, the third in 1850. Each was received with the same attention as the first. Each pushed further into the interconnected structure of the natural world, from the history of the earth recorded in its geology to the distribution of plant and animal communities across the globe, to the influence of climate on human civilization. He was still writing when he was 80 years old. The pace had slowed. His eyesight had weakened. His hand, which had filled thousands of pages of notebook and letter and manuscript across 8 decades of continuous use, tired more quickly than it once had. The mornings at the desk were still there, but they ended sooner. He did not stop. He wrote to a friend in his final years that he had been fortunate in his tiredness, that a man who did not tire was a man who had not worked enough to earn it. He had no complaints about having earned his. The 5th and final volume of Cosmos was not complete when he died. It was published after his death, assembled from his manuscripts. and it is the only one of the 5 that does not have the complete shape he would have given it, but it is recognizably his. In every sentence, the same voice that had been present since the slopes of Chimborazo and the banks of the Orinoco and the winter mornings in Berlin, with the fire just lit and the whole connected universe waiting on the desk to be described. The universe he had spent his life trying to write was larger than any book. He had always known that he had written it anyway, and in the attempt, in the sustained and serious and beautiful attempt across 5 volumes and 2 decades, he had demonstrated something that mattered as much as any of the specific things the books contained. He had demonstrated that the effort was worth making, that the connections were there to be found, that the world, looked at carefully enough, would reveal itself as something magnificent. Chapter 11. The Network Humboldt and His Disciples. There is a particular kind of influence that does not announce itself. It does not arrive as a single dramatic event. It arrives more quietly, through the medium of a conversation or a book or a letter read at exactly the right moment. When a mind is ready for a certain idea and encounters it, and is changed in ways that take years to become fully visible. This was how Humboldt's influence worked. But to understand how it worked, it helps to start not with a famous name or a celebrated discovery, but with a specific scene. A young man on a ship in the South Atlantic in the winter of 1831, sitting in his cabin with a book open on his knees, reading by the light coming through the porthole, occasionally looking up at the sea outside and then back at the page, as though checking whether what the book described matched what his eyes were seeing. The young man was Charles Darwin. He was 22 years old. The ship was the HMS Beagle. The book was Alexander von Humboldt's personal narrative of his travels in South America. Darwin had already read it once before the voyage, in Cambridge, and had read passages of it aloud to his friends with the enthusiasm of someone who has found, in another person's writing, the articulation of something they felt but had not yet been able to say. Those passages about the forests of Venezuela and the extraordinary richness of the tropical world had been part of what convinced him to apply for the position on the Beagle in the first place. On the voyage, he returned to its pages again and again throughout the 5 years of the journey, finding in it a quality of attention to the natural world that matched what the journey was demanding of him. The birds of the Galapagos Islands that resembled birds from the South American mainland, but were not quite the same. The fossil bones in Patagonia that suggested creatures larger than any living today had once walked the same land. The distribution of species across the archipelago that seemed to follow a pattern that no one had yet explained. Humboldt had not written about any of these specific things, but he had given Darwin something more fundamental than specific information. He had given him a way of asking questions. The habit of looking not just at individual things, but at the relationships between them. The understanding that the distribution of species across the globe was not random, but followed patterns that reflected underlying principles. The conviction that those principles could be found, if you looked carefully enough and thought rigorously enough, and were willing to follow the evidence wherever it led. Darwin later wrote in his autobiography that reading Humboldt had stirred in him a burning zeal to contribute to the noble structure of natural science. He was being accurate about a debt that ran through the thinking of the Beagle voyage, even though it could not be found in any single citation. The theory of natural selection was Darwin's alone. The years of observation and the careful, solitary thinking after the Beagle Voyage. The slow and meticulous assembly of evidence and argument that produced On the Origin of Species, this was work that no one else could have done in his place. But the framework within which that thinking happened, the understanding that the living world had a structure and that the structure could be read, this was something he had encountered in significant part in the work of the man whose book he had read until the pages fell apart. The influence on Henry David Thoreau arrived differently. Thoreau was living in Massachusetts in the 1840s and 1850s, working toward the ideas that would become Walden and his other writings about the natural world, and he was struggling with a problem that Humboldt had already solved. The problem of how to write about nature in a way that was both precise and felt, that honoured the scientific demand for accurate observation and the human need to be moved by what was observed. That could describe a pond in winter with enough specificity to satisfy a naturalist and enough beauty to make a reader feel that they were there. He found in Humboldt's writing a demonstration that this was possible, that the language of measurement and the language of wonder were not opposed, that the closer you looked at a thing, the more beautiful it became rather than less, that science and art were not different ways of approaching the natural world, but different instruments for exploring the same territory. His notebooks from this period contain careful, extended engagements with Humboldt's work, returning to the same passages across multiple years, working through what they meant to him and how they connected to what he was observing in the woods and ponds and fields around Concord. When Thoreau writes in Walden about the light on the ice and the sounds of the winter forest and the way the seasons move through the landscape with a logic that rewards patient attention, he is writing in a tradition that Humboldt helped create. The tradition that says the natural world is not a backdrop for human life, but a subject worthy of the same quality of attention we bring to the most serious questions we know how to ask. John Muir came to Humboldt from yet another direction, and what he received was different in kind from what Darwin and Thoreau had taken. Muir was born in Scotland in 1838 and grew up in Wisconsin, and he arrived at his life's work, the study and defense of the wild landscapes of the American West, through a combination of direct experience and reading that included, at a formative moment, Humboldt's published work on the natural history of the Americas. What Humboldt gave Muir was not a method or a language. It was permission to take seriously the feeling he had in the mountains. The feeling that the Sierra Nevada was not simply a collection of geological features and biological specimens, but something whole and alive and possessed of an integrity that deserved to be respected rather than merely used. That feeling was not sentiment, it was perception, and Humboldt's work demonstrated, in the language of serious science, that the perception was accurate. The mountains were connected, the forests were connected, the rivers and the glaciers and the communities of plants and animals were all in conversation with each other in ways that the conventional economic calculus of the era, which asked only what a given piece of land could produce, was completely failing to account for. Muir took this understanding and made it the foundation of the conservation movement that he led for the rest of his life. The National Park System of the United States, which he was instrumental in creating, is among the most direct institutional expressions of Humboldt's ideas anywhere in the world. Every person who walks into Yosemite or Yellowstone on the understanding that these places deserve to be preserved rather than consumed is walking in the long shadow of a man who sat at the edge of a crevasse in Ecuador and drew the world as a living system. Then there was Simón Bolívar, The meeting between Bolivar and Humboldt took place in Paris in the years after the American journey. Bolivar was a young Venezuelan aristocrat in his early 20s, moving through the intellectual circles of the city with the energy and restlessness of someone who was already, without quite knowing it, preparing for the most consequential decades of his life. Humboldt was the most famous scientific authority on South America that existed, recently returned from 5 years in the territories that Bolivar had grown up in and that he was beginning, in his private thinking, to imagine as something other than a Spanish colony. They met at one of the Paris salons where the scientific and political worlds overlapped, and the conversation between them, which Bolivar later referenced as significant in his own account of his intellectual formation, turned quickly to the land. Humboldt talked about what he had seen, not the dramatic encounters with jaguars or electric eels. The other thing, the degradation, the forests cleared for plantations that exhausted the soil within a generation, the rivers altered by colonial agriculture in ways that changed the rainfall patterns of entire regions, the natural systems of South America being dismantled by an economic logic that took everything the land could produce and returned nothing to sustain the systems that produced it. Bolivar listened with the particular attention of a man who is hearing something he has felt but not yet fully articulated. He had grown up on that land. He had seen what Humboldt was describing with his own eyes, without having the scientific framework to understand what he was seeing. Humboldt gave him that framework, and it shaped, in ways that Bolivar's own writings confirm, his thinking about what independence ought to mean, not simply the replacement of Spanish administrators with local ones. A genuinely different relationship between the new nations and the natural world they governed. A relationship that understood the land as a system to be sustained rather than a collection of resources to be extracted. Whether that vision was ever fully realized is a different question, but it was there, in Bolivar's thinking, planted by a conversation in a Paris salon with a German scientist who had spent 5 years measuring the forests and rivers of the continent that Bolivar intended to liberate. These 4 figures represent different tributaries of a single river, a river of influence that began in the forests of Tegel and the mine shafts of Franconia and the rivers of the Orinoco and the slopes of Chimborazo, and flowed outward through 5 decades of published work and correspondence and conversation into the intellectual life of the 19th century and beyond. Humboldt did not found a school or establish a doctrine. He did not require his readers to accept a set of propositions or follow a prescribed method. He offered a way of seeing, and the people who encountered that way of seeing and found that it matched something they had already been reaching toward, those people went back to their own work changed. Darwin's theory, Thoreau's prose, Muir's parks, Bolivar's vision of what independence ought to mean for the land. These are not the same thing. They do not form a unified legacy in the way that a school of thought forms a unified legacy. But they are all marked, in ways that their creators acknowledged, by the passage through them of a single idea, that the natural world is a web, that everything in it is connected, that human beings are part of it, not its managers, and that this fact carries consequences that cannot be indefinitely ignored. One man, one idea, a century of consequences and more. Chapter 12. The Forgetting Why the World Lost Humboldt. Alexander von Humboldt died on the 6th of May, 1859, in his apartment in Berlin, At the age of 89, the city mourned him with the kind of public grief reserved for people who have become, over the course of a long and visible life, part of the fabric of a place. Flags were lowered. The Prussian court went into official mourning. Letters of condolence arrived from scientists and heads of state and ordinary readers across Europe and the Americas. From people who had known him personally and from people who had known him only through his books, but who felt, in the particular way that great writers produce this feeling, that they had lost someone who understood something important about the world and had spent a lifetime trying to share that understanding. The obituaries were extensive and admiring, and then, with a speed that is still striking when you look at the historical record, the world moved on. The forgetting was not immediate. In the years directly following his death, Humboldt's reputation remained at the height it had reached during his lifetime. His books continued to sell. His name was cited in scientific papers across every discipline he had touched. In 1869, the centenary of his birth, the world celebrated him at a scale that reflected how large his reputation still was. Events were held across Europe and the Americas. In New York, a gathering of tens of thousands of people marked the occasion in Central Park. In cities across Latin America, where his work on the natural and political history of the region had made him a figure of particular significance, the celebrations were among the largest public events of the year. It was one of the largest celebrations of a scientist's life that the 19th century produced, and it was, in retrospect, something close to a farewell, because in the decades that followed, Humboldt's reputation began a slow but steady decline that would, by the middle of the 20th century, reduce him from one of the most celebrated scientists in the world to a name that most educated people in the English-speaking world could not place. The reasons for this are worth understanding carefully, because they are not simple and they are not accidental. The first reason announces itself most clearly in the historical record. Humboldt died in the same year that Darwin published On the Origin of Species. The publication of Darwin's book marked a transformation in how science understood the living world, and that transformation, for all the ways it built on foundations that Humboldt had helped lay, pointed scientific culture in a direction that moved away from the kind of work Humboldt had done. Darwin had produced a theory, a single, powerful, explanatory theory that connected an enormous range of observations into a unified account of why living things were the way they were. Natural selection was exactly what scientific culture prized most highly. A mechanism, a principle that could be stated precisely and tested against evidence and used to make predictions. Humboldt had not produced a theory in this sense. He had produced a vision, a way of seeing, a framework for understanding the natural world as a connected system. These things were real and important and enormously influential on the scientists who built on them. But they were not a theory in the Darwinian sense. And as scientific culture in the late 19th century increasingly organized itself around the production and testing of precise theories, the kind of contribution Humboldt had made became harder to recognize and harder to credit. The second reason is the specialization of science. In Humboldt's time, it was just barely possible for a single exceptional mind to hold the major findings of geology and botany and meteorology and oceanography and human geography in a single coherent view, and to see the connections between them. By the end of the 19th century, that was no longer true. Each of the disciplines he had synthesized had expanded enormously, producing specialized literatures that no single scientist could follow in their entirety. Specialization produced results of extraordinary value, but it made the kind of work Humboldt had done, the work of synthesis, of seeing the connections between disciplines, of describing the natural world as a whole, increasingly marginal to the mainstream of scientific culture. He was hard to categorize. He did not belong to any single field, and a scientist who does not belong to a field has no field to champion his legacy. The third reason operated most powerfully in the specific geography of his influence. Humboldt was German. In the first half of the 19th century, this was a considerable advantage. German intellectual culture was at the centre of European scientific life. But the two world wars of the 20th century changed the position of German culture in the world in ways that affected the legacies of German intellectual figures across every field. In the countries whose scientific and cultural institutions increasingly set the terms for international intellectual life through the 20th century, the cultural tradition from which Humboldt came was received with a suspicion that had nothing to do with the quality of the work and everything to do with the catastrophes that Germany had produced. The naturalist societies of Latin America continued to honour his memory, but the centres of scientific power had shifted, and in those centres, the German naturalist who had done his most important work before the American Civil War was not a living presence. The place names remained: Humboldt Bay in California, the Humboldt Current in the Pacific, the Humboldt penguin, the Humboldt squid, the Humboldt lily, more than 300 species, geographical features, and institutions around the world still carry his name, a record of naming that reflects the extraordinary scope of his scientific influence at the moment of his greatest fame. But the names had become empty of the person behind them. A student in California could tell you that Humboldt Bay was a bay on the northern coast of their state. They could not tell you who Humboldt was, or why the bay had been named for him, or what he had understood about the natural world that was still true and still important 2 centuries after he had understood it. The fourth reason is perhaps the most paradoxical of all. Humboldt's ideas had been so thoroughly absorbed into the scientific culture of the century that followed him that they had become invisible as his ideas. The framework of ecology, the understanding of climate as a global system, the recognition of the relationship between human land use and environmental change, the vision of the natural world as a web of connections rather than a collection of separate things. All of these were ideas that Humboldt had helped develop and that had become, by the middle of the 20th century, simply the way that scientists thought about the natural world. When an idea becomes so fundamental that it is no longer attributed to the person who helped introduce it, but is simply assumed as the starting point for further work, that person tends to disappear from the historical record, not because their contribution is being denied, but because it has become so basic that it no longer feels like a contribution. It feels like the flaw. Humboldt had become the flaw. Scientists were standing on him without knowing his name. There is a specific quality to this kind of forgetting that is different from the forgetting that follows a reputation unjustly destroyed. Humboldt's ideas were not rejected or refuted or replaced. They were absorbed and built upon and eventually taken for granted. The world did not decide he was wrong. The world decided he was obvious. It is a kind of tribute that offers no comfort to the person being paid it. His books went out of print in English. His name disappeared from the introductory chapters of the scientific disciplines he had helped to found. Young scientists in fields that owed their conceptual foundations to his work were not taught his name or his history, because the people teaching them had not been taught these things either. The forgetting was passed down through the generations, each generation inheriting not just the science that Humboldt had made possible, but also the ignorance of where that science had come from. And then, in 2015, a book was published in London that began to change this. Andrea Wolff was a historian of ideas who had come to Humboldt through Darwin, following the thread of Darwin's acknowledged debt backward to its source, and found there a figure of extraordinary richness and contemporary relevance that the English-speaking world had almost entirely forgotten. Her book, titled The Invention of Nature, was the first major English-language biography of Humboldt to appear in decades. It told the story of his life and ideas with the rigour of a serious historian and the narrative skill of a writer who understood that the best way to restore a forgotten figure to public consciousness was to make their life as vivid, immediate as the life of a contemporary. The book was received with the kind of enthusiasm that greets the recovery of something genuinely lost. Readers who had never heard of Humboldt found in Wolff's account a scientist whose ideas were not just historically interesting, but urgently relevant to the environmental questions of the present. The man who had described, earlier than almost anyone in modern science, the relationship between human activity and the alteration of landscapes and climate, who had traced the web of connections that made the degradation of one part of the natural system a threat to the whole, who had insisted that human beings were part of nature rather than its managers, was not a figure from a distant and irrelevant past. He was a figure from the very recent past of ideas that the present most urgently needed. The forgetting had lasted 150 years. It was not entirely over. Humboldt was still not a household name in the English-speaking world. His books were still not widely read outside Germany. The work of restoring him to his proper place in the history of science and ideas was still underway. But the direction had changed. The man who had become the flaw was beginning to become visible again. And what people saw, when they looked, was someone who had been trying to tell them something for 2 centuries. Something about connection, about the web of life, about the place of human beings in the natural system they depended on and were in the process of altering in ways that carried costs not yet fully understood, something they very much needed to hear. Chapter 13. Why he matters now more than ever. Let us end where we began. Berlin, 1859. An old man at a desk with a candle burning low. The 5th volume of his life's work, unfinished on the table in front of him. The whole connected universe, still not quite described. Still not quite captured in language adequate to what it actually was. He had spent 89 years in the world. He had measured it, and mapped it, and climbed it, and sailed across it, and listened to the people who lived in it, and written about it in 40 volumes and thousands of letters and lectures that filled the largest halls in Europe. He had given the world a way of seeing that it would spend the next 2 centuries slowly, incompletely, urgently needing to absorb. And now we are here, 200 years after Alexander von Humboldt stood at the edge of a crevasse on Chimborazo and drew the world as a living system. We are living inside the consequences of what happens when the world is not understood that way. When it is understood instead as a collection of resources, a set of separate things to be extracted and consumed without regard for the connections between them. The consequences have names now. Climate change, biodiversity loss, the degradation of water systems that billions of people depend on, the disappearance of species at a rate that has no precedent in the human record. These are not separate problems with separate causes and separate solutions. They are expressions of a single underlying condition, the condition of treating a web as if it were a collection, of acting as though the parts could be removed without cost to the whole. Humboldt described this condition from direct observation in the field, in the forests of Venezuela and on the steppe of Russia, and in the depleted landscapes of the Spanish colonial territories. Beginning in the first years of the 19th century, he described it not as a prophecy or a political argument, but as a scientific observation. He described what he saw and what the measurements showed, and what the comparison of conditions across regions and across decades suggested about where things were heading. He was describing, with the tools and the language available to him at the time, an underlying pattern that the environmental science of our own era documents with instruments and models and datasets he could not have imagined. The underlying pattern is recognizably similar. He saw it earlier than almost anyone in modern science. But the relevance of Humboldt to the present is not only about the specific environmental challenges we face. Urgent as those are, it is about something deeper, something that underlies all of those challenges and that will persist even if some of them are navigated. It is about perception, about how human beings understand their relationship to the natural world. Humboldt believed, and demonstrated through every book he wrote and every lecture he gave, that the fundamental problem was not political or economic, though it had political and economic dimensions. The fundamental problem was that most people did not see the natural world clearly. They saw it as a collection of things, a set of resources, a backdrop against which human life was conducted. They did not see it as a system they were part of, a web of connections whose integrity was inseparable from their own well-being. If they could be helped to see it clearly, he believed, they would act differently. Not all of them, not quickly enough, not without the friction of entrenched interests and institutional inertia and the simple human difficulty of changing behaviour in response to consequences that feel abstract until they are very close. He was not naive about any of this. He had watched the gap between clear evidence and decisive action throughout his entire adult life, and he understood how large that gap could be and how long it could persist. But he believed that the work of making things visible was worth doing, that every person who came to understand the natural world as a connected system rather than a collection of resources was a person whose decisions over the course of a life would be different from the decisions they would otherwise have made, that the accumulation of those different decisions across generations of people who had been helped to see clearly was the only mechanism by which the relationship between human civilization and the natural world could be changed in any durable way. This belief is one of the things his life offers to the present, not a solution, not a guarantee, not the comfort of being told that the problem is manageable and the outcome acceptable if we simply follow the right steps. He did not offer that comfort in his own time, and there is no reason to offer it now on his behalf. But the demonstration, in a life of 89 years of continuous and productive engagement with the hardest questions about the natural world and the human place in it, that the work of understanding is worth doing, that the questions are worth asking, that the connections are worth tracing, the measurements worth taking, the web worth describing again and again in language as clear and as beautiful as you can make it. For as long as you are able to hold a pen, think about the boy in the forests of Tegel. moving through the trees with his lamp, collecting beetles and rocks and the small living things that no one else in his household thought worth noticing, not performing curiosity, not demonstrating anything to anyone, simply paying attention because the world was there and it was extraordinary, and not paying attention to it seemed to him, at a level below conscious decision, simply wrong. That quality of attention, sustained across 89 years and 5 continents and 40 volumes and thousands of letters and a series of ideas that changed how human beings understood the planet they lived on, is what Alexander von Humboldt was. Not a collection of achievements, a way of being in the world, a way that said, quietly and persistently, and with the evidence of a lifetime behind it, that the natural world deserved to be understood, that the connections were real, that the web of life was fragile in ways that mattered, that human beings were part of it rather than its managers, participants rather than observers, and that this fact carried with it responsibilities that could not be delegated to future on the most important questions. The evidence has continued to confirm what he observed. Andrea Wolff, writing about him in 2015, noted that Humboldt gave us a language to understand nature, and with it, a language to recognize what is lost when nature is diminished. She was right, and that language, the language of connection and system and the web of life, is not a historical curiosity. It is the language that the present most urgently needs to speak fluently. The boy from Tegel, the wrong son, the student who stood above the Rhine and understood, for the first time, that a landscape was a conversation, the mining inspector who turned a mine shaft into a laboratory, the explorer who measured electric eels on the Orinoco, the scientist who drew the world on a mountain in Ecuador, the writer who spent 30 years trying to describe the universe and came closer than almost anyone of his century. He looked at the world his entire life and found it, every time, more connected and more magnificent and more at risk than the looking had previously suggested, and he wrote it all down. For us, for this moment, for the morning when we wake up and look out at the natural world and understand, perhaps for the first time, or for the first time in a long time, that what we are looking at is not a backdrop, it is the web. We are part of it, and it needs us to see it clearly. Sleep well.